Hi everyone, this video covers the 7A notes, graph and quadratics. I'm just going to go over the warm-up briefly. So this is just a review of what we learned in the last unit. To factor this expression, you would want to use the perfect square formula, a squared plus 2ab plus b squared, and this equals a plus b squared. In this case, a is 2x and b is 1. So 2x plus 1 squared. Alternatively, you could use AC and then split your b term. It takes a little bit longer, but you would end up with the same answer. Number 2, this is a difference of two squares because m squared is a perfect square and 225 is also a perfect square. This is 15 squared. So in this case, a is m and b is 15. So a plus b, a minus b would be m plus 15, m minus 15. For number 3, this is a regular trinomial where our a term is 1. So we need to think of two numbers that multiply to give us negative 18 and add to give us negative 7. Negative 9 and 2 work for that. So negative 9 times 2 is negative 18. Negative 9 plus 2 is negative 7. So our answer is p minus 9, p plus 2. And finally, number 4. So this one, we have a trinomial where the a term is not 1. So here we need to multiply AC. AC is 5 times negative 21, which is negative 105. So we need to think of two numbers that multiply to give us negative 105, but add to give us 32. Numbers that work, positive 35 and negative 3. Positive 35 times negative 3 is negative 105. Positive 35 minus 3 is positive 32, not negative 32. Sorry about that. There we go. Okay, so I'm going to split my b term to positive 35x and negative 3x. And then I'm going to factor by grouping. The greatest common factor between 5x squared and 35x is 5x. When I factor out the 5x squared divided by 5x is x. 35x divided by 5x is 7. The greatest common factor between negative 3x and negative 21 is negative 3. When I factor out the negative 3, negative 3x divided by negative 3 is positive x. Negative 21 divided by negative 3 is positive 7. And then here, you can see that our parentheses match. That means we did it right. If your parentheses don't match at the end, something went wrong, so go check your previous steps. Our parentheses match, so that's what goes here. In fact, I'll underline it so you can see. And then our two greatest common factors, the 5x and the negative 3, combine to form our other parentheses. And if you're not sure at the end, you can always FOIL this out to make sure you get your original trinomial. All right, moving down to our calculator tutorial. This is zeros of polynomials, and the calculator tutorial is actually, it's not in the 5C notes, it's in a different section, I can't remember, but either way I'm going to go over it again right now. If you graph this on your calculator, I'm going to recommend that you use a standard window of negative 10 to 10 with a scale of 1. First thing you're going to do is just put this equation in next to y1. The x button is right here. xt theta n. The squared button is right here where it says x squared. So I have x squared minus 9, graph. There we go. And what we're looking for specifically is where does this graph hit the x-axis? Now you can tell because we know that the x scale is 1, that means this is counting 1, 2, 3, 4, 5, 6, all the way up to 10. Negative 1, negative 2, negative 3, and so on. If you count the dashes, you can see it hits the x-axis at positive 3 and negative 3. So there's our answer. But let's imagine that it wasn't clear if it hit directly on the dash. It looked like it might be right next to it or in between two dashes. If you're not sure, you're going to use this procedure. Hit second, which is right underneath y equals, and then trace. The second will activate the blue calc right there. 0 is number 2. All right, if we want to find this 0 here, you're going to use the left cursor to move our little cursor over to the left of the desired 0, and then hit enter. Then move the cursor to the right of the desired 0. You want to keep it pretty close, but it doesn't need to be, you need to make sure it's distinctively to the left and to the right. Hit enter, then it will ask you guess, and you're going to hit enter one more time. And it'll tell you that the 0 is x equals negative 3. For zeros, y will always be 0. The answer is going to be your x. So our first answer, negative 3. To find the other one, we do the same thing. Second, calc, 0 is number 2. Left down, you're going to move the cursor to just to the left of the other 0. Enter, right down, enter, guess, enter. And we can see that this is positive 3. All right, number 2, I'm going to clear out this equation and put the new equation in. We've got 3x squared. There we go. Now, it's pretty clear that this hits the origin. Because it hits the origin, we know that x is 0. The x-coordinate where it hits the x-axis is 0. If you try second calc 0, you're going to get an error. And the reason is because the way this works is it needs to have 1 point above the x-axis and 1 point below the x-axis. And in this case, they're both above the x-axis. So as you can see, we got an error, no sign change. So what you would want to do instead, just look at the graph, or you would use trace. Trace is right here, so don't hit the second button, just hit the trace button. And see if you can figure out, in this case, you can see it hits 0, 0. So when y is 0, x is 0. Another way you can do this is using table. For table, you're going to hit second, and then graph. And then you're going to look for what does x equal when y equals 0. All right, let's try this one. We've got 1/3 x squared minus 3 graph. There we go. And we can see that this is negative 3 and 3 also. We can just double check. Left bound, enter. Right bound, enter. Guess, enter. Negative 3. All right, then to find the other 0, second calc 0, I'm going to move to the left of this 0, enter, and then to the right of the 0, enter, guess, enter, and it is 3. So negative 3, 3. All right, and finally, y equals x squared plus 7. Graph it. So if you're looking, where does this graph hit the x-axis? It doesn't. So the answer is no real solution. Now, when you get to Algebra 2, you'll learn that there actually are solutions to this. They're imaginary or complex. But for this class, we're not going to be learning imaginary numbers, so you just need to write no real solution. All right, moving on to the next page. All right, some quick definitions. Standard form of a quadratic function. A quadratic function is a function that can be written in the form y equals ax squared plus bx plus c, where a does not equal 0. We've kind of already gone over this. We've gone over a, b, and c. This is just stating it, so it's in your notes. This form is called the standard form of a quadratic function. Now, the graph of a quadratic function is a U-shaped curve called a parabola. And two aspects of a parabola that you need to know are the axis of symmetry and the vertex. Excuse me. The fold or line that divides the parabola into two matching halves is called the axis of symmetry. So if you took the parabola and you folded it in half and those two halves exactly overlap, that fold, that line, is your axis of symmetry. I usually just write axis for short. The vertex is the highest or lowest point of a parabola. The x-coordinate of the vertex is going to be your axis of symmetry. So remember this formula, x equals negative b over 2a. That's what you're going to use to find your axis of symmetry or the x-coordinate of your vertex. Now, if a, remember your a term is the term attached to the x squared. If a is greater than 0, if a is positive, the parabola opens upward like this. And the vertex is the minimum or the lowest point, like this. If a is less than 0, the parabola opens downward, and the vertex is the maximum point or the highest point of the parabola, like this. There are three types of solutions that you might get. Sometimes the parabola hits the x-axis twice, sometimes it hits it once, and sometimes it does not hit the x-axis at all. If it hits the x-axis twice, there are two solutions. If it hits it once, there's one solution. If it does not hit the x-axis, there are no solutions. Solutions of a quadratic equation: the x-intercepts of the graph are the roots of the equation or the zeros of the function. So solutions, roots, and zeros, those all mean the same thing. All right, example number 1. Identify the domain and range of the function f of x equals negative 3x squared plus 3. If I graph this on my calculator, it's going to look a little bit like this. And this is going to expand horizontally indefinitely. So my range is negative infinity to infinity. Sorry, my domain is negative infinity to infinity. It's all real numbers. But my range is negative infinity to 3, because as you can see, the graph does not pass 3. It doesn't exist up here. And notice that I've put a bracket on the 3 because it includes 3. So domain, negative infinity to infinity, range, negative infinity to 3, including 3. And sorry for the noise in the background. People are starting to come in. I'm going to go as fast as I can. Practice problem number 1. Identify the domain and the range of the function y equals 1/3 x squared. Same thing. The parabola is going to hit the origin. When you graph it on your calculator, it's going to open up kind of a little wider than usual. The domain is negative infinity to infinity. The range is 0 to infinity, including 0. Okay, example number 2. Graph the function, then find the vertex and the axis of symmetry. So here's where we're going to use that formula, x equals negative b minus 2a. So here we're given y equals 5x squared minus 1. There doesn't appear to be a b term, which means our b is 0. So I'm going to plug in 0 for b, and I'm going to plug in 5 for a. Negative 0 divided by 2 times 5 is 0. So the x-coordinate of the vertex is 0. And the axis of symmetry is also 0. To find the y-coordinate, I'm going to plug 0 in for x in this equation. So instead of 5x squared minus 1, I'm going to get 5/0 squared minus 1, which is negative 1. So my vertex is 0, negative 1, x equals 0. And here it is graphically. Here's the vertex, and here is the axis of symmetry. Same thing for number 2. You would graph this on your calculator. It's going to look something like this. The vertex, well, b is negative 6, a is 1. Keep track of your negatives. Negative negative 6 is positive 6. Divided by 2 times 1, that's going to give you 3. So the x-coordinate is going to be 3, and the axis of symmetry is also 3. If you plug 3 into the original equation, you're going to get negative 5 for y. So my vertex is 3, negative 5. So here's the vertex, here's the axis of symmetry, and here it is graphically. All right, I'm going to kind of breeze through example number 3. This is very similar to the calculator tutorial we did earlier. You're going to start by graphing the equation given, in this case x squared minus 3, graph. Then you're going to hit second calc 0. The only difference is this time we're going to get a decimal. So left bound, enter, right bound, enter, guess, enter. We get negative 1.732. And the other one is going to be the positive version of that number. All right, this one, y equals negative x squared minus 5. This one does not hit the x-axis, so there's no real solution. And finally, this is going to be the last one I do in this video because everyone's filing into the class now. We've got negative 2x squared minus 9. Graph it, and you'll notice this one also does not hit the x-axis, so no real solutions. Alright, this is actually where the last Algebra 1 class left off, so I'm going to leave it here. We will go over the rest of the 7A notes next class along with the 7B notes. Your homework due date, I want you to try it. I want you to do as much of it as you can, but the due date will not be next class. It'll be the class after. Thank you so much for watching and have a wonderful day.